Hey everyone, we are back with section 1.5, solving equations with rational numbers. So equations, remember last time we talked about expressions? Those were things that had numbers and variables but no equal signs. Well, equations, they can have numbers or variables or both, but now they have equal signs. So something like 3 plus x equals 2. That's an equation because it has an equal sign. So, yeah, that's what we're going to be doing. We're going to be solving equations with rational numbers. And remember, rational numbers, those are fractions that when converted to decimals, the decimals either terminate, which means they stop, or they repeat. So that's what we're doing today. All right. So whenever we're solving equations, what we're trying to do is we're trying to figure out what the variable is. So in this case, we got m plus 4.6 equals 9. We are trying to figure out what is m. In order to do that, we are going to have to isolate m and get m by itself. Now how we do that is through what is called inverse operations. Oh, I'm going to do inverse operations. Okay? Inverse operations. So let's talk about it. The inverse operation of addition is subtraction. The inverse operation of subtraction is addition. The inverse operation of multiplication is division, and the inverse operation of division is multiplication. There's really all different types of inverse operations. The higher you get in math, the more inverse operations you learn. When you start talking about squared numbers, like x squared, the inverse operation of a squared number is a square root. Okay, a cube number, like x cubed, the inverse operation of a cube number would be a cube root. Or a fourth root number, something that is to the fourth power, the inverse operation would be a fourth root. And then you get higher and higher in math, and maybe you learn about the natural log, and the inverse operation of the natural log is e to the x. And then you just learn all about more and more inverse operations. But for right now, we're not learning all those. Those are, when you get maybe into later algebra and then algebra 2 and trig and all that type of stuff. But today, we're only focusing right here. So addition and subtraction, those are inverse operations. And whenever you see multiplication or division, you're going to do the opposite one to figure out what the variable is. Okay, back to here. What I see is m plus 4.6 equals 9. So I'm trying to get m by itself. Here, this is the equal sign. The equal sign, what it does is it divides the equation into two halves. This is one half, this is the other half, or two sides. So what we want is we want m being the only thing on one side of the equation, okay? So right now, I see this 4.6 on this side. We need to get rid of it. Well, how is 4.6 related to m? Well, it's related to m through addition. So we're going to do the inverse operation, which would be the opposite of a positive 4.6, which would be a negative 4.6, to both sides. All right? A positive 4.6 and negative 4.6, they cancel. We're just left with m equals. Awesome. Now we have m by itself. And we're just going to do this little bit right here. 9 minus 4.6. I'm going to have to add a 0 there, and the 0 is not big enough, so I'm going to have to borrow the 1 from this 9, make that an 8. And I got 10 minus 6, which would be 4, and 8 minus 4, which is 4. So there we go. That is the answer that we have. M equals 4.4. Now, with equations, what I want you to do is check your answer by hand. And how we're going to do that is we are going to write the original equation every single time. Write it up there, okay? And you're just going to write it just how it was up here before we started doing any mumbo jumbo. M equals 4.6 equals 9, okay? And we are going to solve it. We're going to check to see if this is right. So we're going to solve for m equals 4.4. Okay? Substitute it in there. 4.4 plus 4.6 equals 9. Is that true? I don't know. We're going to, add 4.4 plus 4.6 and see. So I'm going to go over here off to the side, go 4.4 plus 4.6. What does it equal? 4 plus 6 is 0. Carry the 1. 4 plus 4 is 8 plus 1 is 9. Drop the decimal, and we get 9. So this equals 9. So we have 9 equals 9. That is a true statement. And what does that mean? Well, that means that the number that we originally substituted in for m is a solution to this original equation. So m equals 4.4 is the solution to the equation m plus 4.6 equals 9. All right, there we go. We checked it. On to the, oh, you can't even see that. I'm sorry. M equals 4.4 is the solution to the equation m plus 4.6, which equals 9, which was our original equation. All right, cool. On to the next example. Here we go. We have 8.2p, and all that means is 8.2 times p equals negative 32.8. Okay, we are trying to figure out what p is, okay? In order to do that, we need to isolate p. We need to get p by itself. So it's the only thing on this side of the equation, okay? Remember the equal sign divides an equation into two sides? Well, right now 8.2 is on the same side as p, and we need to get rid of it. So how is 8.2 related to p? Well, it's related through multiplication. So what's the inverse operation of multiplication? You are correct. It is division. So we are going to divide both sides by whatever this number is, which is 8.2. We're going to do it to both sides. So what happens is, well, what is 8.2? Can you see that? Let me move my finger. 8.2 divided by 8.2. Well, that is 1, and 1 times p is just p. So we now have p all by itself, and we just need to do this little division of decimals. So we got 32, it's a negative 32.8 divided by 8.2. I'm not going to worry about the negative right now. I'm going to deal with that later. So we have 32.8 divided by 8.2. And remember, the only thing you have to remember whenever you're dividing by decimals is that you can never divide by decimals. So we have to change this. We can't have a decimal. So we have to make this not a decimal by moving that decimal place to the right once, and whatever we do to this side, we have to do to this side. So now what we have is 82 divided by 328. All right, let's go for it. Does 82 go into 3? No. Does 82 go into 32? No. Does 82 go into 328? Yeah, how many times? Okay, let's think about it. I'm going to estimate. I'm going to say 82 is like 80. And 328 is like, 330. Well, how many times does 8 go into 330 or 80 into 330? Or I can think about it, how many times does 8 go into 33, which would be, 4? Because I think so, 4. Let's see if this is right. Okay, let's try it. 4 times 2 is 8. And 4 times 8 is 32. Hey, we got it. All right. That's awesome. And the remainder is 0. So, good. That's it. So, that means that 32.8 divided by 8.2 is 4. But now we have to remember, we can't forget about this negative. A negative divided by a positive number is always a negative. So, that's our answer. P equals negative 4. But now we have to check it. So let's check it. And remember, whenever we check it, we have to write the original equation first, just as it was there, okay? So we are going to write 8.2p equals negative 32.8, and we are checking it, evaluating when p is equal to negative 4. So we're going to substitute that in. 8.2 times negative 4. Okay, is this true? I don't know. We got to figure it out. So let's go ahead and do this little multiplication right here. 8.2 times 4. I'm just going to kind of do this off to the side here. I'm going to do this off to the side. And I have 4 times 2, which is 8. 4 times 8, which is 32. And there's a decimal. There's a decimal to the right, one place. So that means I'm just going to move this over 1 right there. And I have 32.8, and remember there's a negative here, and a negative times a positive is going to be a negative. So my answer is negative 32.2, which is the same thing as this, negative 32.8. So that is a true statement, okay? And what does that mean? Well, that means that the number that I stuck in here for P, which was P was equaling negative 4, so P equals negative 4 is the solution to the equation 8.2p equals negative 32.8. That's the answer. All right. Woohoo, we did it. Okay, let's try this one more time. Okay, here we go. Example 1c. Ooh, this looks a little different. We have x divided by 1.2 equaling 15. Okay, we are trying to get x by itself on this side of the equation. Right now, is x by itself? And the answer is no, it's not. There is this 1.2. Well, how is the 1.2 related to x? Well, it's related through this little line, which means division, right? So this means x divided by 1.2. So if we want to get x by itself, we have to do the inverse operation of division, which would be multiplication. So we are just going to multiply both sides by 1.2, whatever number this is. So this is how I want you to show your work. You're just going to do a little dot there, which means multiplication. 1.2 multiply by this side and multiply by this side. 1.2. Okay? Now what's going to happen here is this 1.2 is going to cancel out with that 1.2 because 1.2 over 1, you look to cross cancel, right? And 1.2 goes into 1.2 one time and 1.2 goes into 1.2 one time. And then you just multiply across and you get 1 times x, which is x, and then 1 times 1 on the bottom, and x over 1 is just the same thing as x. So we've isolated x. X is now by itself. So we are going to do this little multiplication right here. 15 times 1.2. Okay, let's do it. Okay, 2 times 5, what is it? It's 10. Write the 0, carry the 1. 2 times 1 is 2, plus the 1 is 3. Then we have the 0, and then 1 times 5 is 5, and 1 times 1 would be 1. There we go. 0 plus 0 is 0, 3 plus 5 is 8, and the 1 is 180. Okay, and then we are looking for the decimal. Okay, there's one decimal. How many places are there to the right of the decimal? Well, here there's only one place. So that means I'm going to move this over 1. So the answer is 18. So x equals 18. Awesome. Okay, now we need to check our answer. So we're going to check. We're going to write the original problem here, just as it is. You're going to do this every single time, and you're going to evaluate for when x equals 18. So that means we're going to put 18 in for x. Instead of writing x, I'm writing 18, and then I'm kind of just writing everything else. So I have 18 divided by 1.2 equals 15. Cool. Now I just need to do this little division right here. So I'm going to go off to the side and go 18 divided by 1.2. So 18 divided by 1.2. Okay. Okay, the first thing you have to remember, 18 divided by 1/2. Whenever you are dividing by decimals, is that you can never divide by decimals. So we need to change this. We are going to move this over one place, and that means the decimal here is going to move over one place. Now, since there is no number there, we're going to add a 0. So this is the same thing as going 12 divided by 180. Cool, let's do it. Does 12 go into 1? No. Does 12 go into 18? Yes. How many times? 1. 1 times 12 is 12. We subtract 18 from 12 and we get 6. And then we do our favorite thing. We drop it like it's hot. Okay, we have 60. 12 goes into 60 how many times? I'm going to say I think it goes in 5 times. 5 times 2 is 10. Carry the 1. 5 times 1 is 5 plus 1 is 6. And there we have it. It goes in 15 times. All right, so yeah. That means that 18 divided by 1.2 is 15. This is a true statement. Woohoo, we did it. All right. Okay, so what does this mean? This means it's a true statement, which means that the number that we put in for x is the solution to the original equation. So x equals 18 is the solution to the equation